Okay, so hopefully you tried to set that up on your own and maybe got an answer. I have the work on the back board here so you can check if you tried it or if you just skipped ahead and wanted to see me do it. Either way, I don't care. I can't yell at you on the video, right? So here's the solution. So basically well, to remind you what we're doing, we want to find the volume of revolution formed by the square root curve between 1 and 4 rotated around the x-axis. So how do you do that with what I showed you? Well, it's always good, like I said, to get a picture. So I drew one. Square root of x looks something like that. There's the section from 1 to 4. So this sort of purpley shaded region is what's going to be revolved. If you start spinning this thing around the x-axis, you get a shape like what's down here. It sort of looks like it's on its side, but looks like a cereal bowl or a soup bowl or something, right? So it's got a flat part, top and bottom, but it's curved on the sides, and you can find the volume of what this is. So basically, the thing I calculate is if this area were spun around the x-axis and traced out this bowl shape, how much volume is in that bowl, which is something that without calculus would not be easy to find. At least it wouldn't be easy to find the exact version. Maybe you could fill it with liquid and use maybe a scientific way to try to approximate it. But the nice thing about calculus is we can come up with the precise area of this thing. All right. So what is the area of this, or sorry, I should say the volume. What's the volume of this bowl shape? Well, my function is square root of x. I'm going from 1 to 4, and that's really all I need to know. If I want to find that volume of revolution, I'm going to use the formula. So the formula says put pi on the outside, integrate from a to b of the function all squared, and throw a little dx on it. So my volume in this particular case is going to be pi, the integral from 1 to 4 of the square root curve squared dx. Now, you could just throw this into a calculator. The problem is throwing it directly into a calculator. It's going to give you some decimal, it'll give you that end answer. Since we're not going crazy with solving these things, if you want to just throw it in from here and get an answer, I'm fine with that. I decided to break it into pieces to show you a little more precisely what the answer is, the more mathematically exact answer. If I leave the pi separate, squaring the square root function is going to give me x. I'm going to integrate from 1 to 4 of x dx. Now, if you wanted to do this by hand, the antiderivative of this is pretty easy. It's 1/2 x squared. You could plug in 4, plug in 1, subtract them. If you did that, you would get 15 halves or 7.5. Since I did that separately, this integral part's 7.5, but don't forget the pi. So my answer is 7.5 pi, or fraction-wise, 15 pi over 2. So the exact volume of this bowl shape is 15 pi halves, or 7.5 pi. That rounds to approximately, to the nearest hundredth, 23.56 cubic units. So remember, these are measuring volume. So I didn't give you what the units were, but say the units were inches, we'd get cubic inches. All right, so that's how you find the volume. Basically, this formula works so as long as you're going around the x-axis and you have the function and the parts you want to cut off, you can rotate this around and find any volume. So there's different shapes that can be found this way. Now, unfortunately, it has to be some kind of circular shape for this to work. There are ways to find volumes of other three-dimensional things, but this is the easiest ways to solve revolution. If you want to learn other things, you got to take more calculus and do some more advanced methods. But these aren't the only volumes you can find, but these are the easiest ones. And basically, from here, there's lots of other things you can do with this. You can rotate around other lines. There's a way to rotate around a vertical line. You can also do, like in the last video, you can take area between curves and rotate them. That's basically what the rest of the course would have done. We don't have time for it, so at least if you get this concept, you've seen a volume of revolution, know what it is, and know the generic way of solving it. All the other more advanced things are just modifications to this formula. Like if you want to revolve it around another line, there's a way to like subtract the line off. If you want to do it area between two curves, you can just put in the two functions instead of the one. So it's things like that. So if you go on, this general idea is what's used to do all the rest of the more advanced stuff. All right, but basically it's this formula, and think of it this way. If you didn't have the squared and the pi on it, you'd just be finding the area. Basically, you're taking that area and you want to make it circular, so you're actually throwing it into like the circle formula. You're taking that area, squaring it, and multiplying it times pi. An area of a circle is pi r squared. So by taking that area and sort of making circular regions out of it and integrating across those circular regions, adding up all those little circular discs basically gives you that volume across. So that's what this formula is. And I feel like if you understand area of a circle, it makes sense that this sort of takes the slices that you get and turns them into those cylindrical pieces that you need. All right, but so try the assignment. Basically, the assignment gives you a function, gives you a domain to go over. If you just throw it into this formula and throw it into a calculator, you can call it a day. All right, so that's unfortunately all we had time for. So that ends your AP Calculus. If you've gotten this far, once again, thanks for working so hard, and get that last assignment in. And if you got all your assignments in, hopefully I can give you a really good grade and end the school year right. All right, so as always, stay safe, and all you guys are seniors, so enjoy your graduation as much as you can in these weird circumstances, because you've definitely earned it. All right, take care.